Hey everyone, welcome to Chapter 3. We are now getting into multi-step equations, and we're going to start talking about solving multi-step inequalities. So some of the skills that we need to have in order to be successful are kind of shown in the following two problems. So I'd like you to pause the video, solve these two problems, play the video when you're done, and see if you get it right. Alright, so I hope you looked at this one and said, okay, an equivalent variable expression, okay, using the distributive property. Well, that means distribute. What do you distribute? The 9 to the x and then the 9 to the negative 4. So what's 9 times x? It's 9x. And what's 9 times negative 4? Negative 36 or minus 36, and that would be your equivalent variable expression. Down here, I hope you saw like terms with 9b and negative 12b. Remember, that sign belongs to the 12, so it's a 9b and a negative 12b. And so 9 minus 12 would give you negative 3, and we're talking about b's. And then we're adding this 3, haven't touched him, and I can't simplify any further because 3 and negative 3b, they are not like terms. So you're done. Alright, so those are kind of some of the simple skills that we need to know going forward. I'm sure you guys did fine on those. If not, that's totally okay. Just make sure you're good with those concepts as we move forward. Alright, so we are starting on 3.1, naturally, and we are going to be solving two-step equations. Alright, so here's our third problem for the video. 3x plus 6 equals 12. Now you see an equal sign in a variable, so that means what? It means we're going to solve. Okay, and we're solving for what? For x. And again, we're solving an equation. We want our variable to be by himself at the end equal to some number. So, when we have two-step equations, we have to be very careful in what we do because we almost use the opposite of order of operations to solve. And what do I mean? Well, if you remember, order of operations is GEMDAS. Grouping symbols first, then exponents, then multiplication, division, then addition, subtraction. And I wanted to be clear that we're not totally throwing order of operations out the window completely because we use order of operations to simplify expressions, right? Because if I had 3 times 2 plus 1, I would do that right there, okay, 3 times 2, which is 6, then this plus 1, and 6 plus 1 is 7. Okay, so I'm still obeying order of operations, and even if we had 3 times 2 plus 1 equals x plus 2x, okay, I would still over here do the multiplication first. I'm not going to, just because it's an equation doesn't mean I'm going to do this 2 plus 1 and go in reverse. That's not what I'm talking about. And so if this isn't clear, it'll become clear really quick. So up here in this equation, if we notice the x is not by himself like he needs to be because, for one, he's being multiplied by a 3. And there's also a plus 6 on this side of the equation. And remember, I need to get the x by himself, so what do? Well, order of operations would say, oh, you have addition there and multiplication there. You got to deal with the multiplication first. And how would we get that 3 by himself? Well, I would divide by 3. And it's not wrong to do that, but I think it's simpler if we go, like I said, opposite of order of operations. What do I mean by that? Well, I mean, I'm going to deal with this plus 6 first before getting rid of that 3, okay? So how do I get rid of a plus 6? Well, I'm going to do the inverse operation, which is subtraction, and I'm subtracting 6. If I subtract 6 from one side, got to subtract it from the other side. So now I'm left with 3x, those cancel, is equal to 6. Okay, we can all agree upon that. And now what's my last step? Well, I have 3 times x. How do I get rid of a multiplication of 3? I divide by 3. If I divide that side by 3, I have to divide this side by 3 as well. So what happens here is those cancel, or they both become 1 and 1, which would give me 1x over 1, which we could just simplify to be plain old x, which is what we have down there waiting for us. And 6 divided by 3 is 2. Your x is by itself, and you're done. All right, so that's what I mean about kind of going in opposite of order of operations. Notice we dealt with the addition first, then we dealt with the multiplication. And we used the inverse operations to deal with the addition and the inverse operation to deal with the multiplication. All right, for those of you guys who are a little more visual as we learn, we're going to solve the same problem, but using what are called algebra tiles. Okay, so we have 3x plus 6 equals 12. How we're going to solve this using tiles, I'll show you. Each one of these green tiles is going to be worth an x. Okay, so each green rectangle is an x, and then each yellow square is worth 1. Okay, so if I'm going to set up this equation using tiles, well, I'm going to say, all right, how many x's do I have on that side of the equation? 3. So I'm going to pull down 3. Right? And I'm adding to those 3 what? Well, I'm adding to them 6. 6 what? Well, 6 ones, we could think of it, right? 6 is the same as 1 plus 1 plus 1 plus 1 plus 1 plus 1. So let's move down 6 of these. There you go. So before we move on to the second part, just make sure you're clear. Each one of these greens is worth x, and so just kind of put that back up there so for your reference, and each little yellow tile is worth 1. So we have this side of the equation right here, 3 x's plus 6 ones, okay, which is the same as just saying 6. And that's equal to 12, so I'm going to put 12 yellow boxes over here. All right, just like that. So how does this help us solve this equation? Well, basically what we're trying to do is we're going to work backwards to kind of undo some things to try and get x by itself, okay? Or we could think of, let's look at both sides and see, is there anything we can cancel? Well, if you think about it, here I have 6 yellow tiles and here I have 12, okay? Well, again, I'm trying to get x by itself, which really means like 1 green tile by itself. So, well, if there's 6 yellow tiles on both sides, I could cancel 6 here and 6 there. So what am I left with? I'm left with this. All right, so there we go. So now you might be asking, well, how do we cancel things? You got some greens and some yellows now, and I understand up here how we could cancel 1 yellow for 1 yellow and another yellow for another yellow and so on and so forth. But what about these? Well, maybe it's better not to think of canceling yellows and greens, but to ask ourselves, well, let's see, for every green tile, how many yellow tiles are there? Well, for every green, there are 2 yellows. So you can see I have them lined up for a reason. For this green, there are 2 there. And for this green, there are 2 there. And what does each green stand for? Well, each green, again, we set up here, stands for an x. So for each x, we have 2 yellow tiles, or 2 tiles that are worth 1. And we keep our equal sign, and all of a sudden, we have our answer. Now, is that what we got on the last problem, or when we did it the first way? Yeah, right there. Okay, so if that helps you, you are so more than welcome to keep investigating what that's like to use algebra tiles, and I can help you with that. If you don't like it, totally fine. All right, so I want you to pause the video, try this problem, see if you get the right answer, play it when you're done, and yeah, we'll keep on moving. All right, so I hope you remember that we kind of do almost opposite of order of operations, and I'm going to deal with the plus 1 first, because again, our goal is what? Get x by itself. And how do I do that? Well, how do I deal with this plus 1? Well, I'm going to do the inverse of plus, or addition, which is subtraction. I'm going to subtract 1 from both sides. So here on the left side, I'm left with 4x plus 1 minus 1 cancels, equals 4 minus 5 is 4. Then what do I do? Well, I got to get 4 by itself. It's being multiplied by x, so let's do the inverse of multiplication, which is division. Divide by 4 on both sides. And what do you get? Well, those cancel there, leaving you with just x equals 4 over 4 is 1. Now, let me show you something, because I did say we need to subtract the 1 first and not divide by the 4 first, but it's not wrong if we do, but let me show you why we want to subtract by 1 first and not divide by 4 first. Okay? So if I divide it by 4, it's fine. I can do that first. But if I divide one thing by 4, Or if I multiply something by 4 in an equation, I have to multiply or divide every single thing. So that means the 4x divides by 4. The other side divides by 4. But this 1 also gets divided by 4. So what does that leave us with? Well, 4x over 4 is just x, because those cancel. But that's x plus a fourth, and that equals, well, 5 over 4. I could just leave that 5/4. Okay. Now I got to get x by itself, so how do I do that? Well, I have a plus 1/4, so the only way to get rid of a plus 1/4, or to make it 0, is to subtract 1/4 from both sides. Okay. And when I do that, I get x plus a fourth minus a fourth cancels equals, well, let's see, 5/4 minus a fourth. It might be better to set it up horizontally. Common denominator, so that's good. So 5 minus 4 is, or 5 minus 1 is 4 over 4. 4 over 4 is 1. Okay, so x is equal to 1, and we got x equal to 1 over here, and you can see we got the same answer. So it's not wrong to divide by 4 first, but a lot of times we get put into situations where we have fractions, and I don't know, I like to avoid them whenever I can. I like working with integers or whole numbers a lot more than I like working with fractions. So just so you know, it's not wrong to divide by 4 first, but I think this way is preferred. All right, so let's mix in a little division and subtraction here. So I have x divided by 2 minus 3 equals 1. Okay, I have a variable, I have an equal sign, means it's an equation, means I'm going to solve that equation, and I want x to be equal to some number and the end. So how do I do that? Well, again, we're going to kind of do the opposite of order of operations. I know in order to get rid of this divide by 2, I'm going to have to multiply by 2 at some point. Okay, and in order to get rid of this minus 3, I'm going to have to add 3 at some point. But again, I'm going to deal with the subtraction first, and then deal with this division by 2. So how do I deal with the minus 3? I'm going to add 3. If I add 3 to one side of the equation, I have to add it to the other, and I'm left with x over 2 minus 3 plus 3 cancels, equals 1, and 3 gets you 4. So how do you get rid of that 2? Well, again, you're going to multiply both sides of the equation by 2. On this side, I'm going to make it 2 over 1, so I'm multiplying a fraction by a fraction. Here, I'm just going to take it times the integer 2. And what do I get over here? Well, again, cancel, cancel, or become 1 and 1, and that leaves me with 1 times x, which is x, over 1 times 1, which is just 1, and that equals 4 times 2, which is 8. And if I simplify this, again, anything over 1 is just itself, so x over 1 is really just like x equals 8. And we're done. All right, so again, we added first, then we dealt with multiplication. All right, so why don't you take a minute, I want you to try this one, solve for m. All right, so hopefully you remembered, I got multiply by 2 there, and I have a plus 6 or a positive 6 here. Going to have to get rid of him, and I have to get rid of this negative 2 somehow. So what do I do first? Well, again, I'm going to deal with any addition or subtraction first before I deal with this multiplication. Now, do I have any addition or subtraction? Well, yeah. And it doesn't really look like it, but if you think about this 6, he's a positive 6, right? You could say 6 is being added to this side of the equation. So how do I get rid of that plus 6 or positive 6? I'm going to subtract 6. But if I subtract 6 from one side, I'm going to subtract it from the other. 6 minus 6 cancels. Leaves me with negative 2m, keep that sign, equals 8 minus 6, which is 2. Got to solve for m, so I'm going to divide by negative 2 on both sides of the equation. Negative 2 over negative 2, we could just say they cancel, become m, and that equals 2 divided by negative 2, which of course is negative 1, and you're done. All right, so let's say that you are going to buy a drum set, okay? And you're not going to pay all for it all up front. You're going to get on a payment plan, okay? We're going to say the total cost of the set is going to be $495. Right? But you make a down payment of, let's see, 150. Okay. 150. All right, so the total is $495. You make a down payment of $150. Okay, and then what you're going to do is you are going to pay the rest off in 3 payments. and one per month. All right. So what we're going to do is we want to construct an equation. Okay, because yes, we can kind of like play with some numbers and kind of guess at this and figure this out. But we want to construct an equation. That's the important thing here. Okay, and when you're constructing the equation, I want you to look for the word total, or a number that is a total. Okay, and so the total cost is what? Well, it's $4.95. So I'm going to write $4.95 equals. Okay, when I see a total, I'm going to write that total and set it equal to. Now, what do I set it equal to? Well, keep in mind it's $495, so whatever I put over here also has to be in terms of dollars. All right. So how do I get to that $495? We make a down payment of $150. And then what else do you do? Well, you make 3 payments, right? So 150 plus 3, right? Well, not quite. Now, 3 is the number of payments, but the question is, how much is the payment? Well, I don't know, but I know I'm making 3 payments, so I'm going to turn this into a 3P. 3 payments times the amount of each payment. And now all of a sudden I have an equation and we know how to solve these equations, okay? Again, what's our goal? The goal is to get the P by itself, and it's on the right side of the equation, which is totally fine, and so I want it to look like P equals some number, okay? Now, why is P not by himself? Well, he's being multiplied by 3, and there's a positive 150 on this side. So how do I get those things out of there? Well, remember, first I deal with the integers, okay, or just the plain numbers, the constant terms, okay. So I'm going to subtract 150 because I want to make that go away, which is going to make it 0, or I could say it cancels. But if I subtract 150 from one side, I have to subtract 150 from the other side. So when you take 495 minus 150, what do you get? You get $345. And that's equal to, well, 150 minus 150, we said it canceled, so you're left with a 3P. All right, your last step, well, P is being multiplied by 3, so let's divide it by 3 on both sides. And when you get 345 divided by 3, those cancel, and you get P to equal 115. Okay, otherwise known as $115. So what is $115? The amount of each payment you're going to make once a month for 3 months, and then you will have paid off your drum set. All right, that's all I have for you guys. I look forward to seeing you in class.